Momentum is a quantity that keeps an object in a state of motion. Think of it as how difficult it is to change the motion of a moving object. It depends on two variables, the velocity and the mass. We'll come back to this part in a second. The formula for momentum is mass times velocity. Mass is abbreviated with an m, and velocity uses a v. So momentum can also be an m because that was already used for mass. So the abbreviation for momentum is p. Why p, you ask? Well, basically, it comes from the Latin word for momentum. Let's try a quick sample problem using this formula. What is the momentum of a 5 kilogram cart traveling at a velocity of 3 meters per second? The first thing we do is write our formula. Then we plug in our numbers. 5 kilograms is the mass, the velocity is 3 meters per second. 5 times 3 is 15. But we do need a unit. To figure out the unit, we have to look at the formula. It is an unusual unit. Mass is measured in kilograms, and velocity is measured in meters per second. Since the formula is mass times velocity, the unit is kilograms times meters per second. So back to our problem, our final answer is 15 kilograms times meters per second. Now you can see from this math formula that if the mass increases, the momentum increases as well, since mass and velocity are being multiplied. For example, let's double the mass in our sample problem. Now, what is the momentum of a 10 kilogram cart traveling at a velocity of 3 meters per second? First thing we do is write our formula, mass times velocity, plug our numbers in, 10 kilograms times 3 meters per second, and it equals 30 kilograms times meters per second. Now notice that doubling the mass doubled the momentum. There's a direct relationship here. Now that makes sense. A real car and a ride-on car have very different momentums when traveling at the same speed, and it's much harder to change the real car's motion.
Momentum depends on mass, and the more mass there is, the more momentum there is.
Now we can see from the formula that if the velocity is increased, the momentum will increase as well, because mass and velocity are being multiplied. So let's try doubling the velocity of the object in our sample problem 1 and seeing how that affects the momentum. What is the momentum of a 5 kilogram cart traveling at a velocity of 6 meters per second? The first thing we do is write our formula. P equals m times v. We plug our values in. 5 kilograms times 6 meters per second equals 30 kilograms times meters per second. We can see that when the velocity is doubled from 3 to 6, the momentum increases, but it actually doubles. 15 kilograms times meters per second to 30 kilograms times meters per second. And that makes sense. A fast-moving car has much more momentum than a slower-moving car, and it is harder to change the faster car's motion.
Momentum also depends on velocity. The higher the velocity, the more momentum there is. Now it's time for you to try some math.
Let's work out the momentum of a 100 kilogram mass moving at a velocity of 5 meters per second. Now to do that, we'll need the formula that we've been learning about. Momentum equals mass times velocity. We can use abbreviations to make it a little bit faster.
Why don't you try to calculate the momentum? Pause the video and plug the mass and velocity into the formula and calculate the momentum. I will give you the answer and how to calculate it so you can check your answer.
So the mass is 100 kilograms, and we're multiplying that by the velocity, meters per second. That gives us a momentum of 500 kilograms times meters per second. We just worked out that the object had a momentum of 500 kilograms times meters per second. Now what were to happen if the mass of that object were to increase? Let's say we have a 400 kilogram object also traveling at 5 meters per second. We will once again use the same formula, P equals m times v, and we plug our numbers in.
Why don't you try to calculate the momentum? Pause the video and plug the mass and velocity into the formula and calculate the momentum. I will give you the answer and how to calculate it so you can check your answer.
400 kilograms times 5 meters per second. We work that out and we get a momentum of 2,000 kilograms times meters per second. Now you'll notice that increasing the mass increased the momentum from 500 to 2,000 kilograms times meters per second. Now, if we look really closely, we'll see that we increased the mass by 4 times, and the momentum was increased by 4 times. Let's work out another problem. We'll go back to our 100 kilogram mass, but we'll have this mass travel at a higher speed, and we'll see how that affects the momentum. So now we'll have it travel at 25 meters per second. We have the same formula, momentum equals mass times velocity.
Why don't you try to calculate the momentum? Pause the video and plug the mass and velocity into the formula and calculate the momentum. I will give you the answer and how to calculate it so you can check your answer.
We plug in our value for mass, and we plug in our value for velocity, and from the formula we get a momentum of 2,500 kilograms times meters per second. Now we can see here that as the velocity increased from 5 to 25 meters per second, the momentum got larger, and that makes sense. If we look closely though, we'll see that the velocity was increased by 5 times from 5 to 25, and that increased the momentum from 500 all the way to 2,500. So if you increase the velocity by 5 times, the momentum increases by 5 times. Let's put this all together with one final problem. What if we were to increase the mass and the velocity? So what if the mass was increased by 4 times and the velocity was increased by 5 times? Well, our formula is still P equals m times v. Now, what we have done is increased the mass by 4 times, and we have increased the velocity by 5 times. So 4 times 5 is 20. So we should have a momentum that is 20 times larger. Let's see if that follows.
Why don't you try to calculate the momentum? Pause the video and plug the mass and velocity into the formula and calculate the momentum. I will give you the answer and how to calculate it so you can check your answer.
We use the same formula, P equals m times v. The mass is 400 and the velocity is 25. 400 times 25 is 10,000. Don't forget that unit. Kilograms times meters per second. Now what we found is we increased the mass by 4, the velocity by 5, and that should give a momentum 20 times larger. And we started out with a momentum of 500 kilograms times meters per second. Multiply that by 20 and you get 10,000 kilograms times meters per second. So 20 times the momentum when you increase the mass by 4 and the velocity by 5.
So remember, momentum is what keeps an object in its state of motion. It depends on the velocity and the mass. And the formula is mass times velocity.